Victor Black.
Victor Black.
Uncle Victor.
Victor Black Masterclasses.
Mr. Victor Black.
Virtual Victor, the safer use model.
Genomic steroid action from conversion to action. So far, we've covered how steroid hormones are produced, transported, and biotransformed. Now we move to the most important question: what do these hormones actually do? This is where steroid action occurs. Steroids cause effects in two ways: genomic actions and non-genomic actions. Today we're focusing on genomic action, the primary driver of muscle growth. What is genomic action? Genomic action begins when a steroid hormone binds to its specific receptor. This hormone receptor complex then moves into the cell nucleus. There it interacts with DNA at something called a gene response element. This interaction tells the cell which proteins to produce. In skeletal muscle, that means protein synthesis. This is the main mechanism by which all anabolic steroids build muscle. The androgen receptor and muscle growth. When an androgen binds to the androgen receptor, gene transcription is activated. That transcription leads to the creation of proteins that build new muscle tissue and reduce muscle breakdown. This is the core purpose of anabolic steroids. Everything else, hardness, dryness, strength, is secondary. At the molecular level, they all work by activating protein synthesis. Agonists versus antagonists. Not all compounds act the same at receptors. Some act as agonists, meaning they activate the receptor. Others act as antagonists, meaning they block it. Some compounds do both, depending on the tissue. Tamoxifen is a good example. In breast tissue, it blocks estrogen. In bone tissue, it acts like estrogen. This tissue-specific behavior is critical for understanding drug effects. Binding strength is not everything. A common myth is that stronger receptor binding means better muscle growth. That's not always true. Oxymethylone, for example, binds weakly to the androgen receptor, yet it is extremely effective at building muscle. This tells us that muscle growth is not determined by binding strength alone. Some compounds exert powerful effects through non-genomic mechanisms as well. All steroids share the same primary job. Steroids often get labeled with nicknames: dry, hard, strong, filling, but those labels are misleading. Every anabolic steroid primarily does the same thing: increase protein synthesis and reduce muscle breakdown. Stack design becomes much simpler when you understand this. You need enough anabolic signaling to build muscle. Compound choice is about side effects, not magic properties. Tissue-specific gene effects. Different tissues respond differently to the same hormones. Androgens and estrogens can upregulate or downregulate genes depending on the tissue. For example, in the skin, androgens increase sebum production. Estrogens decrease it. That's why high androgen, low estrogen states often cause acne. Hormone balance matters. Breast tissue and estrogen balance. In breast tissue, androgens oppose estrogen-driven growth. This is why compounds like masteron were used in breast cancer treatment. When gynecomastia occurs, it's not just about estrogen levels. It's about the ratio between estrogens and androgens. Changing that ratio can change tissue response. HBG, hair, and skin. Androgens reduce sex hormone binding globulin. Estrogens increase it. In hair follicles, androgens promote hair loss. Estrogens promote hair growth. This is why high androgen, low estrogen states often lead to thinning hair and dry skin. Estrogen isn't the enemy, it has protective roles. Fat distribution and receptors. Fat tissue also responds differently based on receptor type. Subcutaneous fat has more estrogen receptors. Visceral fat has more androgen receptors. High estrogen favors subcutaneous fat storage. High androgens favor visceral fat accumulation. This helps explain gender-specific fat patterns and PED-related changes in fat distribution. Why compounds feel different. Most anabolic steroids build muscle at similar rates. Where they differ is in how they affect other tissues. One compound may impact lipids more, another may impact hair or skin. This is why one athlete tolerates primobolan well but struggles with masteron, or vice versa. It's not about muscle, it's about tissue selectivity. Coaching takeaway. Genomic Action explains everything. Muscle growth, side effects, individual response. PED design isn't about chasing magic compounds. It's about finding the right balance of anabolic effect with the lowest cost to other tissues. That balance is individual, and that's where real coaching lives.
Victor Black.
Victor Black.
Uncle Victor.
Victor Black Masterclasses.
Mr. Victor Black.
Virtual Victor, the safer used model.